Okay, hello. Welcome to this video. Today we're going to be talking about how to identify the oxidation states of different elements and compounds, as well as identifying which compounds are being oxidized and reduced. So to begin with, we'll start out with these two compounds, H2CO3 and NO2-. So let's begin by first assigning the oxidation states of each compound in H2CO3. So I have our periodic table right here. And so when we're assigning oxidation states, we want to first assign those which are most common or most repetitive. And what I mean by that is oxygen will almost always take the form of a 2-, and there's 3 oxygens in total in that compound. Carbon we'll come back to, and hydrogen will almost always take the form of +1, and there's 2 hydrogens in this compound. Now the reason carbon has not been assigned yet is because carbon, because of its location on the periodic table, can either adopt a +4 or a -4 charge state. And which one that will be, we will see soon. So another thing that we have to consider is the overall charge of the molecule. So it's neutral, because there's no plus or minus charge over here, which means that all of these charges have to cancel out. So if then the compound is neutral and we have a total of 6 negative charges and 2 positive charges, so if we have -6 plus x, x being carbon, let's put a question mark, plus 2 is equal to 0, well, we can do a little math. So if we add 6 to that side, then we get 6 and 2 plus x. So then x must be equal to 4. So then that means that carbon is actually adopting a +4 state. So we would have oxygen as a -2, carbon as +4, and hydrogen as +1. And I'll actually just box that in a different color. Let's do blue, and I'll box those in a different color. Okay, so now let's look at NO2-. So as I said before, start with those compounds that you're sure of. So let's look at nitrogen and oxygen. So as we said before, oxygen will most likely adopt a 2- charge, and there's 2 of those in that compound. Nitrogen, we don't know. So let's put a question mark, and call it X. So we also know that the overall charge on the molecule has to be a -1. So what we can do is we can say we have -4 for oxygen plus X for nitrogen, and there's only one of those, equals -1. So what that means is that X has to be +3 then. So if X equals +3, then the oxidation state of nitrogen also has to be +3. So we look at that and we say, okay, oxygen has -2, and nitrogen has +3. And I'll box that just like the other one before we move on to the last example. Okay, so on the next slide, let's look at this in terms of reaction. So here we have chromium and tin. We have chromium plus and tin 4+, and those obviously change their charge states, as you see. So the question is, which one is being reduced and which one is being oxidized? So there's a little acronym that I like to use. It's called oil rig. I'm sure you guys have heard this before. Oops, what happened there? Oil rig. So oil stands for oxidation is lost or lose, and rig stands for reduction is gain. This will become more natural to you the more you do it. But what that's referring to is the amount of electrons. So let's look at chromium, Cr. So here chromium occupies a +1 state. And over here it occupies a +3 state. The reason that shift in charge states occur, in oxidation states occur, is because chromium is actually losing electrons. So if you think about it, electrons are these negatively charged little circles. And the more you have of them, the more negative your element is going to be, right? So if you lose a lot of negatively charged molecules, then you will make your molecule more positive. So if you increase the number of negatively charged particles, electrons, then you decrease the oxidation state. And if you decrease the number of negatively charged particles, electrons, you increase the oxidation state. So here, chromium goes from a +1 to a +3. So it's gaining, its oxidation state is increasing. So this means that chromium is being oxidized. So Cr equals oxidized. Tin, on the other hand, is going from a +4 to a +2. So that's a reduction in oxidation states. And as we said here, an increase in electrons results in a decrease in oxidation states. And if you're increasing your electrons, you're also gaining electrons. So that means tin is being reduced. Okay, so in the next video we'll talk about how to identify which compound is being oxidized and which compound is being reduced. Thank you for watching.